introducing and good morning everyone. As Scott just mentioned, so this webinar is part of the series of webinars that we had planned for our region. So we had sales webinar a few weeks ago, and we discussed the high level architecture, the high level details, I mean the big picture of an all IP architecture. And it started with like whether we need an SBC or not. So but in this session, so we will dig bit deeper into it, and we will discuss the technical aspect of it. So let's start with the presentation. So I would start with the first thing is what kind of network and what are we talking about. So we are talking about a network wherein if you can see this rectangle on your screen. Okay, so this rectangle is actually a operate a customer network. So and when this customer network connects to an ITSP, so which is on the other hand side, on the right hand side, so this is a basic customer setup where he's connected via an NBN router, as you can see in the center. So this is the NBN router in the center, and how we can basically look at this session border controller, what it is, how it is deployed, where it is deployed, and what does it offers. All these features we'll discuss now. So the very first thing, what is the session border controller? So basically a session border controller is a device, okay, as you can see here. This device, which basically is deployed in a voice over IP infrastructure when you have a customer who needs to connect to an voice over IP network, and this session border controller is basically involved in like setting up or conducting or tearing down of the calls. Not only calls, it's basically an interactive media communication. So the session border controller, as the name suggests, this is a full session state device. Okay, basically it manages the complete session of from the setting up of the call to tearing down of the call. Okay, while it like maintains that state, it is responsible for the security. When we say security, like any malicious attack or denial of service attack from outside, or a distributed denial of service attacks, or the topology hiding your local internal network from the outside world, and encryption, like it should be able to take care of the TLS or the IPsec and media, I mean the SRTP streams. And then when we talk about the connectivity part, it should be able to do the NAT reversal. It should be able to do IPv4 to IPv6 internet working or VPN connectivity, or it should be able to do the protocol translation. Sometimes you might require SIP normalization, like one side supporting one kind of SIP, the other side supporting other kind of SIP. Then quality of service, a major aspect when it's maintaining a session. It should look at how it can apply policies to the traffic, how it can do resource allocation, how it can do rate limitation, the call admission control, and sometimes you might end up in looking at the regulatory aspect of it, like you want to do emergency call prioritization. Okay, there could be media services which might require some help, like in terms of if you want to relay DTMF media, you want to do media transcoding. Okay, then this device, because it controls everything which is going on voice over IP through itself. So basically this device should be able to provide you with the statistics of how your network is performing and how the voice and the call quality of the voice is being maintained in your network. Now the next question is where it sits in your network. So this session border controller, it can sit next to your NBN router, or like if we like talk about NBN infrastructure, it might not be exactly NBN router. There would be an NTU or something device which would be terminating the fiber interface. So this device can basically connect through that fiber interface, and it can talk to the network over the NBN like network. Now, or okay, like this this is like something wherein this device can completely replace the edge devices, and you can connect to the NBN network, where they would give you an Ethernet interface out of the NTU. So this device can connect directly to the NBN network, and it can take care of the voice and data now. Okay, like in previously we have seen that this ESBC was only taking care of the voice part, but it can also take care of the voice and data part both. And then this device can also sit inside or behind your NBN router. Okay, so where it can do the policing, it can provide quality of service, but it would be dependent on the NBN router, so that it can say that, okay, I'm doing my own QoS. Okay, I'm setting up these parameters. I'm setting up TOS. I'm setting up COS parameters. Okay, now these NBN routers, if these are intelligent enough to look at those parameters, they'll be able to route the traffic efficiently. Next thing, who needs it? Whether the service provider needs it or the enterprise needs it, who needs this device? So we'll try to answer this question in the next slides, which are coming up. So now here in the next slide, so in our previous session, okay, we discussed about this entire network, okay, because when we start talking about this voice over IP, the future of voice over IP, we are looking at the SIP on the towards the northbound interfaces. We are looking at SIP towards the inside of the network. We have got SIP IP phones. We have got SIP-based IP PBXs, which is the future. Okay, it might be possible that today it could be just a SIP on the northbound interface and PSTN on the southbound interfaces, or it could be like PSTN on both sides, where the customer might be looking at positioning this device in such a way so that tomorrow, in case if it's an all SIP network, you should be able to take care of the entire infrastructure, and you should be able to connect to PSTN on both sides. In case if PSTN is not available, you should be able to connect to SIP, and if it's entirely a SIP environment, you should be able to take care of the survivability and the service quality of the voice network. So basically security, survivability, and service quality. So these are the main three aspects which this device has to take care of. Now, some people come and say, oh, we have got a firewall in a network. Okay, there's a firewall. We don't need a session border controller, because what they say that, okay, a session border controller is just a firewall. But if we have got a firewall, is this firewall effective enough to look at the SIP traffic? Can it manage the quality of service of the voice traffic? And is it optimized for SIP? So these are the questions which the firewall, some firewalls like which are like available, or which are like available on the routers or the modems, so they are not able to answer these questions. Now, what in case if your network, like the network which is towards the northbound side, this network goes down? What is the fallback? Is there any alternate SIP route available? How should you take care of your voice communication in case if your NBN network or your network towards the northbound interface goes down? So these are the questions which are raised the moment we start talking about a session border controller, or like we start talking about SIP. So these questions are raised at that time. Now, if we talk about security, how Patton session border controllers can provide security, the first and the foremost thing is it can do a SIP attack prevention. So basically we talk about security. Okay, we talk about the malicious attacks. So this device, you can configure the device that any SIP packet, in case if somebody is trying to flood your network with the SIP packets from outside, this device can prevent it. How it can prevent it? Irrespective of what type of SIP packet is coming, it can start counting the maximum number of packets within a particular time frame, and then based on that counting of packets in real time, thus you can define what should be the block time. If you start receiving n number of packets, or you start receiving more number of packets than the predefined SIP packets, it should start blocking those. And then you can define the overload state, whether in normal working condition, what it should do, what it should do in warning state condition, what it should do in critical conditions. Like in warning condition, you can say, okay, if you are getting being flooded with SIP, and you can say that, okay, when this device reaches a warning condition, it should stop sending a SIP register message. It should deny more registrations, or it should deny more invite messages. It should take care of the existing calls. Or in critical, you can say, okay, no other messages, only SIP invite. Okay, so these are the various ways how you can define overload state, and you can mitigate the SIP attacks which can come from outside. You can define the maximum number of queued SIP packets. Okay, how many packets the system can process. Okay, you can even define that. Okay, when the when suppose I can say that, okay, my queue should only have like 50 or 60 or 70 packets inside, and it should not go beyond 50 or 60 packets. It should start discarding the packets after that. So basically, in that ways, you are preventing your device, your network from getting flooded with SIP. Now, the next thing is the access control list. Now, this is what, okay, we know about firewall. A firewall can be implemented through a modem or a router. Okay, now these Patton devices, these do offer an access control list, which basically implements a stateful firewall. A stateful firewall would mean that it will take care of the connection state. It will look at the connection state, and basically you can define applications like for SIP. It's a SIP where it is aware about the FTP protocol. It's aware about the TFTP, and basically these applications, it maintains the state of these applications so that you don't have to like specifically define the netting or any other stuff for these applications. And then we have got like exhaustive packet matching criteria, which is based on around 32 parameters. Okay, we look at the IP address, the source IP, the destination IP, the MAC address, and so many things from the packet. And based on those things, we match these packets inside our firewall, and then based on these, we define these deny and permit rules on the incoming or on the outgoing traffic at the interface level, and this is how we implement the firewall inside a device. Then these also do a DNS security check. Now, what's a DNS security check? Basically, it's like possible to configure to like register only, like using the contact, if it matches the address which is like previously received from the DNS resolution. So basically, you can define a check DNS address, and whenever it receives a register request or it receives a redirection response for a register request, it will look at the contact field, the request which is in the contact field, and it can check the DNS, and then it can basically apply the DNS security there. And you can also define your trusted host list based on the IP address, the fully qualified domain name, or the remote party address. So how you can define is, you just have to, inside the interface, you have to trust the remote fully qualified domain name or the IP address. So, and here, like what I've shown is like you can create an interface, and then you can attach a profile, ACL profile, to a incoming traffic on the WAN interface. So that's how it works, the access control list. And then the other thing which is part of security is back-to-back UA. We can do a call separation between incoming and outgoing call legs. We can, these calls, like when our incoming call comes in and we generate an outgoing call out of it, we tear down all parameters. So we can generate a brand new call when it goes out, or we can create a complete back-to-back UA wherein we will only register to an outside entity when we receive a register request from my identity which is sitting inside my network. Okay, we can translate the call parameters. We can translate the request URI, the to header, the from header when a call goes out of my this device, out of this device. Or you can even translate when the call is coming into the device, the user registrations. Okay, each site can separately authenticate as incoming or outgoing SIP trunk. It can act as an inbound SIP trunk, or it can act as an outbound SIP trunk. Okay, we can do dynamic B2B registration, as I've told you, that once we receive the registration request from the LAN side, we can register it on the WAN side accordingly. We can do a media bypass detection, and the call parameters we can write like dynamic registrars for outbound calls, and the NAT reversal is also possible in our back-to-back UA. Now, then we talk about advanced call routing. Now, this is at the application level. We can verify all the call parameters. We can look at the calling party, called party, the contact header, all these parameters. We can change it. We can verify these parameters at the application level. Now, this is in addition to what is being at the firewall. At firewall, we are just looking at the packets, at the SIP packets. Now, here we have opened up the packets. We are looking what is inside those packets. We can check the number ranges, who is calling whom. We can manage restrictions, okay, imposed by the neighboring equipment. Okay, they might have a small CLI of 4 digits. We can change that CLI from 4 digit to 10 digit and send the call out. We can look at the privacy headers. We can manage those privacy headers, and then we can control where the call should go out, which interface the call should take, and then we can define fallback strategies. Like when a call goes out, if one interface is not available, automatically the call should fall back to second interface. We can restrict the call rates. We can restrict the simultaneous call. Now, this is at application level. I can say if a call is coming from X number or X calling number, I should only accept 5 calls or 10 calls or 20 calls or per second. Or I can say I will only accept 20 simultaneous calls. It can be coming at any rate. Okay, it can come at 5 calls per second, or it can come at 10 calls per second. So, but I will only accept 10, 20, or 30 simultaneous calls through an interface. Now, the other thing which is part of security is the secure SIP application. Okay, we support TLS SRTP, so we can support it without TLS authentication, with mutual TLS for mutually exchange, or we can generate our own certificates. We can generate certificates for devices. We can act as a certification authority on a device, and we can also work with MTLS in a Microsoft Link environment. Now, the next thing is the service quality. Like when we talk about service quality, let's just try to understand the network first. Okay, we talk about a network, okay, wherein we have got a data network first. Our data laptop connects to internet, and this is how it's working. So this is the one part. So this is the ITSP or the NBN infrastructure which is there, and then on top of it, over the top service provider, they would provide voice over IP services. Okay, like this could be the NBN. NBN is providing the basic services for the internet, or somebody would be providing these services on top of it, and then like once these services are these are the internet services which are provided, and then on top of it we have got the SIP trunk or the voice services which are provided by over the top providers which would provide these services. Now, this is a very basic setup, and for this communication, for this voice over IP communication, we would also be using the same pipe to go to our internet, to our SIP service provider. Now, what happens here is that this Ethernet pipe can become a bottleneck. How it can become a bottleneck? When we get a traffic from our laptops or our other kind of data traffic, and then we have got this voice traffic which is also using the same pipe, so this can become a bottleneck very easily. Now, if we introduce a Patton device here which is sitting behind the router or the modem, okay, for an I'm just taking an example where we have got ITSP and over the top provider, and we are putting this Patton device behind it. Now, this device is responsible for QoS and monitoring. Okay, now what it does, it will ensure the quality of voice over IP service. It will provide the quality of service for the voice priority. So when a data traffic comes in, or when the voice over IP traffic comes in, it would provide priority to this traffic to go through first, and then the second, the data traffic which is there, it will it will be given a lesser priority over the voice traffic. Now, this device can do proactive traffic monitoring. It can sense what is coming in, what is going out. You can do a packet capture. You can do debugging. You can do sniffing of the traffic, and then how this is all done. Okay, the very first thing which comes here is actually you have to classify the traffic. So whenever like for this quality of service, we do the packet classification. We check the incoming traffic. We have got this classifier profiles. We match the protocol. We look at the ports. We check that, okay, whether it's a SIP traffic, it's an RTP traffic, or is it any other kind of data traffic which is coming in. This traffic, when it passes through a classifier, we assign a traffic class to these different kind of traffic. Okay, so this could be signaling traffic, the RTP traffic, and then any other kind of telnet, HTTP, or any other traffic. Now, once this classification is done, then all other components which are there inside SBC, they will take care. They will use like ACL or policy routing or the service policy. They will use this classification to actually route the traffic accordingly to the interfaces. Now, this is just a very basic overview of how like traffic comes in and goes out. Okay, like at the lower layer, we look at the packet, what is there inside the packet to identify the COS and the TOS values. Okay, based on this, we can do the mapping. We can pass it to a higher layers. We can this is done at done at the port level. Okay, then we can add our classifiers at the higher layers. Okay, so but at the lower layers, we pick up from the IP part of the packet. We pick up the type of service. We pick up the COS from 802.1 PQ segment of the packet. So and then when the traffic goes in or when the traffic goes out, okay, we can tag the traffic. We can tag TOS and COS values when the traffic goes out through the other port. So this is basically the mapping which is possible on our devices. Now this is just a very high level architecture. Like we have got this data traffic which is coming in. We have got voice traffic which is coming in. When it comes to the port, okay, we can classify the traffic this data traffic. We can classify that, okay, this is a data traffic. It should be given a different priority, or it should be going through a separate VLAN, and then this is how it will go out. Now, when we talk about voice traffic, you can define a voice traffic. It gets classified as a voice traffic, and then it can take a different path. Now, this is the voice traffic which is coming from inside your LAN network. Now, there could be voice traffic which is generated by the device itself. Now, that traffic is coming from the local interface. It is classified through the same through the same voice tagging. So, and then it can also take a different route or the same route as the other voice traffic. And then the local traffic, the management traffic which is generated, it can be taking a separate route to go out through the network. Now, this is how this entire box works. So basically, we can classify traffic, we can assign priorities, we can say, okay, which traffic should go out first, or which traffic should go out second, or which traffic should have priority, or the traffic can be passed out through different VLANs going out of the device. Now, there could be a different device which could be like looking at various VLANs and deciding priorities. So we can even like define our own priorities, and we can put it to different VLANs when the traffic goes out. Now, the next thing is we talk about survivability. Now, in survivability, this is the last topic here. So in survivability, what we do is like this device provides a USB interface, okay, through which you can connect a 3G, 4G dongle to the device, and this would provide a fallback path in case if like somebody starts just like your fiber gets cut for some reason or the other, and the NBN network is not available, or your ITSP is not able to provide you internet services. So you can fall back to another 3G, 4G dongle backup. So if you're not reachable from outside, okay, you can fall back with an ESBC. We have got this functionality available on the device where you can connect your any 3G or 4G or LTE dongle to the device, and it can work, or it can provide a fallback path to your traffic. It would be responsible for the call routing. You can define hunt groups. You can use SIP options to decide the alternate route, or you can even use rules and actions. I'll explain you in the next slide what it's all about. Now, what all devices we support on our USB interface, it is available on our website as trinityusbmodems.asp. So you can use this link to look at the devices which we support as of now. But in case if there is any device which you need support for, and it's not like readily, you just connect and it's not working, we can make it work for you. So now how we support this 4G is we support it with Qualcomm chipset, and most of the vendors like ZTE, Novotel Wireless, or Sierra Wireless, the manufacturers of all the vendors who manufacture these devices or whose chips are there in these devices. So we support these guys. Like just to give an example, okay, this is how we can configure an Optus device, which is Huawei E3372 USB device. Okay, so you can just create an interface. You can define the APN, and that's it. The moment you define this, you just bring it up, you enable it, and this USB dongle can connect as now this is available as a separate IP interface, and you can just like start using it immediately the moment you connect the modem. So this is how like basically it works. Then we have got the one thing which I just told you in my last slide, that we have got action triggers, or the rules and actions. So we can define rules inside the device that based on few system variables or the IP variables, SIP variables, for example. What you can do is we have got few variables inside the system. Okay, you can see it with a show variable command, whether the LAN interface is up, whether the cellular is up, whether the WAN interface is up, what is the NTP status, what is the SIP status, what are the other system parameters, what basically the system health parameters. Now, based on these parameters, you can decide what action to take. Okay, so for example, here what I did is like in case if the SIP gateway is not registered, okay, and or I mean this is a second condition, or the WAN link is down. Okay, so what to do in these cases? Okay, just shut down the LAN side port. So I just created a rule, okay, just an example, but you won't ever be shutting down the LAN port. So in case if you want to enable the LAN automatically, the moment the gateway gets registered or the WAN link comes up, the LAN will automatically be enabled, because this command will automatically enable the Ethernet interface 01, which is on the device. So this is how you can define rules and actions within a session border controller. Now, which are the products which qualify as a session border controller, or the products which we offer as a session border controllers? We have got SM5200 and 5300 series. Now, these are pure SIP session border devices. They comes with 5 and 4 Ethernet interfaces. They don't have any telephone interfaces, and they don't offer any kind of transcoding. Then we have got 5480 and 5490. These devices do offer transcoding in addition to the SIP sessions. Okay, and if we move further, then these devices which are here, these would also offer you PSTN interfaces on the device, along with transcoding as well as SIP to SIP sessions. And then some of these devices do come with additional WAN access interface. Now, this is in addition to the USB interface. Okay, so it can come with VDSL, ADSL, 0TS, HDSL, or X.21 interfaces on the device. And then all of these devices offer IP router functionality. You can look at the number of Ethernet ports. And then these devices are, other than the first two devices, all of these devices offer transcoding up to like 64 calls or 8 calls or 6 calls or 2 calls, depending on which model you are picking up. And then the key takeaways. So basically, we couldn't simulate the other SBCs in the market, so we made it better ourselves. So why Patton is a better choice as an ESBC? We have got router capabilities. We are a back-to-back UA. We offer edge security, transcoding, and voice over IP profiles are like one of the best in the class. So we offer alternate and advanced routing options. We do traffic optimization. We have a broad range of interoperability with the devices available in the in the market. So we offer seamless migration strategies. We have got zero-touch provisioning and the service provider integration. So we have got this is like engineered for enterprise requirements. We have got licensing and wrapping up modularity. We can do a licensing, a floating license kind of a stuff. We have got like world-class customer support services, which you all know about. And then why is it a smart choice for SME? It's a cost-effective, it's a reliable device, it's interop with major soft switches and IPPBXs. We have got more than 1,000 plus scenarios tested and passed on our devices. We have got our own in-house production. It's a Swiss engineered product, and RMA rate is less than 0.5%. So with that, I would now switch to questions and answers. So let me see if we have got any questions. So Scott, do we have any questions?
Not a lot. So there's a few questions that came through which we've already answered. But if we just want to clarify, so Jason was asking about QoS on the actual NBN network. So once the traffic leaves the Patton box and goes onto the WAN side, you know,
Yep.
How do we handle that? Because there's no QoS on the actual NBN network itself.
Okay, so basically what we do is we have got this, as I've told you, we have got this TOS mapping. Okay, we can do this TOS or DSCP bit setting for the quality of service if it is implemented on the NBN network. Okay, because till the time that we control the network, okay, we can control which traffic is given priority. Now, in case if we see that, okay, the voice traffic is getting delayed or the packets are getting delayed, okay, we can throttle the data traffic. Okay, when we throttle the data traffic, we know that, okay, we have got much more bandwidth to take the voice traffic over it, or we can then switch to other coders. Okay, we can switch to 07 to 9 so that at least the call is handled properly. Or in case if all of these parameters are not available, we can even fall back to the USB interface. Okay, in case if you see that, okay, the calls are not going through or something is going on with the calls. So we have got a lot of possibilities to work around that.
So Jagdeep, just on that, so if a call has poor quality, will it automatically fail over to the 4G network based on quality, or will the call have to fail before it fails over to the 4G network?
The call has to fail.
Yeah. Okay.
The call has to fail.
Yep.
As of now.
Yeah.
As of now, the call has to fail, but we are definitely, yeah, that's actually part of our this thing which we are doing now.
Okay. Okay, guys, is there any other questions before we wrap things up? If you do have any questions that you want to ask over the or via audio, just raise your hand in the question panel and we can unmute you and you can ask your questions.
And the other thing, in case if you hadn't gone, like if you see that I was a bit fast or I was a bit quick and like presenting my this webinar, so what what Scott told you, like we will be we have recorded this webinar and we will be uploading it on the website, and you can go through the webinar again once again just to make sure in case if you don't understand anything, or like you can write to like Scott, you can write to me. We are available. You can write to like support at loi.com.au, and you will be able to get an answer to the questions.
Okay, Larry's just asked via the question panel, are Huawei USB dongles supported?
Yes, as I've just shown you in my previous slide. Okay, let me just go back to that slide. Yes, this slide. Okay, so like this example which we did on which I just shown here, this is done with Huawei E3372. Now this is a LTE USB stick which is from Optus. So we tested that, like not tested that, I'm like using it almost every day. So just as a fallback device to my existing NBN network.
Okay, then we had another question from Bruce. Can the PRI port be used as an interface to a non-SIP based PBX?
Yes, that's right. That's in fact a very good question. Okay, on our SN5570 series, which is the ESBC with the PRI interfaces, this device comes with a unique configuration on the E1 pinouts that you can connect one E1 directly to the SIP provider. The other side, the other port can be connected directly to your local network. And in case even if the box goes down for some reason, that there's no power on the box, this device can automatically relay the traffic which is coming from the WAN side, from the network side to the PBX, even if there is no power on the unit. So it can relay the entire traffic. It actually switches the traffic together.
Okay, and then also if you don't have an E1 connection from your provider anymore, and all you want to do is add SIP connectivity to a traditional PBX with an E1 interface, we can do that too. So we can just route calls from the E1 port or the primary rate port on the Patton box out via a SIP provider as well.
That's right, Scott.
Yep. Okay, guys, any other questions? Okay, do you have a version which is also a VDSL modem? So the answer is yes for that.
Yes.
But at this point, I don't know if there is Australian compliance for those models. So that makes it a little bit more difficult for us to use them.
Yeah, so we offer like VDSL, ADSL, and zero to HDSL interfaces on our devices. Definitely.
Okay, guys. Any other questions? I think that looks like it's about it. Jagdeep, thank you very much once again.
Yeah, thank you, Scott, and thanks everyone for joining into the webinar, and we really appreciate your time. Thank you.
Okay, so Bruce, yes, what I'll do, Bruce, is I'll shoot you through an email with what I might do actually, I'll get your account manager to contact you, and we'll send you through some pricing for these products. Okay, guys, thank you very much. We appreciate your time. Thank you once again, Jagdeep, and we look forward to seeing you all at Alloy's and Patton's next webinar. Thank you.
Thanks. Thank you.